Alright, recording lowest common multiples and greatest common factors, take 3. Hopefully this works. So we talked a little about the LCM the other day in class. I'm just going to repeat that. To find the lowest common multiple of two numbers, you can multiply the highest power of each of the prime factors. Now, to do that you need to have the prime factorization. So let's work with 18 and 60. To find the prime factorization of a number, you make a factor tree. So 2 goes into 18 9 times, 3 goes into 9 3. So 18 must be equal to 2 times 3 squared. 60, 2 goes into that 30 times, 2 goes into 30 15, 3 goes into 15 5 times. So its prime factorization is 2 squared times 3 times 5, which I've noted here. To find the LCM, we want to multiply together the highest power of each prime factor. While 2 as a prime factor occurs here and here, this is really 2 to the first. 2 to the second is the highest power of 2, so I have to write that down. Similarly, 3 squared is what I choose. 5 is the only power of 5 around, so I choose that. Multiplying those out, we get 180. If you tried to remove any one of these factors, like one of the 3's or the 5 or a 2, you'll have a number that either 18 or 60 won't go into. So that makes 180 the smallest number that both 18 and 60 will go into. So there's some homework problems you get to test that theory out on. Greatest common factor or greatest common divisor. Multiply the lowest power of the common prime factors. A little bit different strategy. Let's take 18 and 60 again. So here we want to find the lowest power of the common primes. So 2 is common to both and 3 is common to both, but 5 is not. So 5 will not be part of the greatest common divisor or greatest common factor. Lowest power of 2 is 2 to the first. Lowest power of 3 is 3 to the first. So multiplying those, 2 times 3 gives me 6. Now notice something interesting here. We choose this 2 and that 3 for the GCF. We choose the 2 squared, 3 squared, and 5 for the LCM. The 2 and the 3 are not chosen from the GCD, so the highlighted numbers here form the LCM, the other two numbers form the GCD, and it turns out that always works for a pair of numbers. We take all the factors combined of the numbers you're looking at. The LCM forms one set, the GCD forms another, and together they contain all the information about 18 and 60. Another way to look at that would be to say, if you were to multiply 18 and 60 together, you'd get the same answer as if you multiplied the LCM times the GCD. And that works all the time, which is kind of cool. Alright, that's it for this recording. I have one more on order of operations. See you soon.